My next guest, Harvard astrophysicist Avi Loeb, has suggested the three-eye atlas is actually some type of alien technology.
September 8, 2025. At 1427 UTC, every alarm in NASA's Deep Space Network began screaming simultaneously. The 7-mile-wide interstellar visitor 3I/ATLAS had just executed an impossible maneuver, a deliberate course correction that defied every law of physics governing celestial motion. In 72 hours, this cosmic giant, traveling at 60 kilometers per second, somehow changed direction with surgical precision, leaving NASA's orbital dynamics team staring at calculations that refused to balance. Something with the intelligence to navigate our solar system was now actively steering toward Earth. The impossible maneuver that stunned NASA. At exactly 1427 UTC on September 6, 2025, the Deep Space Network registered the first anomalous readings from 3I/ATLAS that would shatter our understanding of how objects move through space. The interstellar visitor, which had been following a predictable hyperbolic trajectory since its discovery, suddenly began executing a series of course corrections that defied every principle of orbital mechanics. The maneuver wasn't subtle. It was a deliberate alteration of trajectory that changed the object's path by several thousand kilometers over a period of just 3 days. What makes this impossible is the sheer physics involved. For an object massing billions of tons to change course so dramatically would require forces equivalent to multiple rocket engines firing continuously, yet no propulsion signatures were detected by any monitoring station on Earth. The initial trajectory calculations had been precise, verified by observatories across 6 continents. 3I/ATLAS was following a clean hyperbolic orbit with an eccentricity of 6.141, a path so mathematically perfect it could have been drawn with a compass. Then something changed. The object began deviating from its predicted course in ways that suggested controlled flight rather than natural celestial motion. NASA's Jet Propulsion Laboratory immediately activated emergency protocols, bringing together the world's leading orbital dynamics experts to analyze what they were witnessing. The deviation patterns showed characteristics that only appear in artificially controlled spacecraft: smooth acceleration curves, precise directional changes, and most disturbing of all, apparent awareness of gravitational influences that shouldn't affect the object for weeks. The European Space Agency's trajectory analysis revealed that 3I/ATLAS was somehow anticipating and compensating for gravitational perturbations from Jupiter and Saturn before those influences should have been detectable. This level of predictive navigation requires computational capabilities and sensor systems that exceed our most advanced space technology by decades. Radio telescopes monitoring the object detected no electromagnetic emissions that could indicate active propulsion systems. Infrared observations showed no thermal signatures consistent with conventional rocket engines. Yet, the object continued altering its course with mechanical precision, as if guided by an intelligence that understood our solar system's gravitational architecture better than we do. The most unsettling aspect of the maneuver was its apparent purposefulness. The trajectory changes weren't random or chaotic. They followed a logical sequence that optimized the object's path for maximum observation opportunities of Earth, Mars, and the outer planets. It was conducting a systematic survey of our solar system while demonstrating technological capabilities that make our space program look primitive. The chemical signature that defies nature. The spectroscopic analysis of 3I/ATLAS has revealed a chemical composition so unusual that it challenges our fundamental understanding of how matter forms in the universe. The James Webb Space Telescope's detailed examination of the object's coma has detected molecular ratios and elemental signatures that simply don't occur naturally in any known cosmic environment. The carbon dioxide to water ratio of 8:1 represents an astronomical impossibility for natural comet formation. Every comet in our solar system and every model of comet formation in other systems predicts water ice as the dominant volatile component. Carbon dioxide typically appears as a minor constituent, never as the primary gas. Yet 3I/A TLAS is ejecting 129 kilograms of carbon dioxide per second, while releasing only 6.6 kilograms of water per second. This inverted chemistry suggests formation conditions that don't exist in nature. The molecular structure indicates that the carbon dioxide isn't simply frozen within the nucleus, but is being actively generated through processes that require precise temperature and pressure controls. The isotopic ratios of carbon-12 to carbon-13 show patterns consistent with industrial production rather than stellar nucleosynthesis. Even more disturbing is the presence of pure nickel emissions detected by the Very Large Telescope. The spectroscopic signature shows 22 distinct nickel emission lines with an intensity that indicates the metal is being vaporized and ejected at a rate of 4.7 times 10 to the power of 22 atoms per second. What makes this impossible is the complete absence of iron, which always accompanies nickel in natural cosmic materials. They're formed together in stellar cores and remain chemically bound in meteorites and asteroids. The separation of nickel from iron requires industrial processes involving temperatures exceeding 2,800 degrees Celsius and controlled atmospheric conditions that prevent oxidation. Such purification techniques weren't developed by human civilization until the 20th century. Yet this interstellar object is somehow producing streams of pure nickel as it travels through the vacuum of space. Organic compound analysis has revealed complex hydrocarbon chains that don't match any known biological or geological processes. The molecular structures include synthetic polymers and aromatic compounds that are typically produced through controlled chemical reactions. These aren't the simple organic molecules that form in interstellar space. They're sophisticated materials that require deliberate engineering. The dust particles being ejected from 3I/ATLAS show geometric regularity under electron microscope analysis. Instead of the irregular fractal structures typical of cosmic dust, these particles display crystalline lattices and uniform dimensions that suggest manufactured origin. The dust composition includes titanium-aluminum alloys in proportions that optimize strength-to-weight ratios, similar to aerospace engineering applications. The gravitational anomaly that breaks physics. The gravitational behavior of 3I/ATLAS has forced physicists to confront the possibility that our understanding of gravity itself might be incomplete. The object's interaction with our solar system's gravitational field displays characteristics that contradict Einstein's general relativity and Newton's laws of motion in ways that can't be explained by measurement errors or unknown mass distributions. Gravitational mapping using data from multiple space-based observatories reveals that 3I/ATLAS is generating its own localized gravitational field that doesn't correlate with its estimated mass. The field strength varies in patterns that suggest active gravitational manipulation rather than the static field that should surround any massive object. This variation occurs on timescales of hours rather than the geological ages required for natural gravitational changes. The object's gravitational signature shows what physicists describe as negative mass characteristics in certain regions around its perimeter. These areas appear to repel matter rather than attract it, creating gravitational gradients that shouldn't exist according to our current understanding of physics. The phenomenon is so pronounced that it's affecting the orbital mechanics of small asteroids and debris within a 50,000-kilometer radius. Most significantly, 3I/ATLAS appears to be selectively interacting with different types of matter based on their composition. Rocky materials experience normal gravitational attraction, while metallic objects show anomalous repulsion effects. This selective gravity suggests technology that can discriminate between different atomic structures and apply gravitational forces accordingly. The gravitational anomalies are creating measurable distortions in space-time that radio astronomy teams are detecting through changes in signal propagation. Radio waves passing near 3I/ATL, AS show frequency. Shifts and timing delays that indicate the object is somehow bending space-time more severely than its apparent mass should allow. These distortions follow patterns that suggest controlled manipulation rather than natural gravitational lensing. Theoretical physicists analyzing the data are confronting the possibility that 3I/ATLAS represents technology that operates on principles beyond our current scientific framework. The gravitational effects being observed would require mastery of exotic matter, negative energy densities, or manipulation of fundamental forces that we can only describe mathematically but have never seen implemented practically. The implications extend beyond just this single object. If technology exists that can artificially generate and manipulate gravitational fields, it represents capabilities that could revolutionize transportation, energy generation, and our basic understanding of physics. The fact that such technology is apparently traversing our solar system suggests we're being observed by intelligence with scientific capabilities that exceed our own by centuries or millennia. The propulsion system that shouldn't exist. The analysis of 3I/ATLAS's movement patterns has revealed propulsion characteristics that operate on principles completely unknown to human science. The object demonstrates controlled acceleration and deceleration capabilities that produce no detectable exhaust signatures, electromagnetic emissions, or thermal byproducts that would indicate conventional propulsion systems. The acceleration profiles recorded by tracking stations worldwide show smooth, continuous thrust applications that maintain constant specific impulse regardless of the object's velocity or proximity to gravitational sources. This consistency is impossible with chemical rockets, ion drives, or any propulsion technology in our current arsenal. The thrust-to-weight ratios being achieved would require exhaust velocities approaching significant fractions of light speed. Infrared monitoring has failed to detect any heat signatures that would indicate energy conversion processes necessary for propulsion. The object maintains thermal equilibrium with its environment while simultaneously demonstrating acceleration capabilities that should generate massive thermal emissions. This suggests either perfect energy efficiency or the use of exotic energy sources that don't produce waste heat. The directional control demonstrated by 3I/ATLAS indicates omnidirectional thrust capability, without any visible attitude control systems. The object can change its vector of acceleration instantaneously, without the gradual reorientation maneuvers required by conventional spacecraft. This level of control requires either multiple propulsion systems operating in perfect coordination or a single system that can redirect thrust through three-dimensional space without mechanical movement. Spectroscopic analysis during acceleration phases shows no evidence of propellant ejection. Traditional rockets work by throwing mass in one direction to generate thrust in the opposite direction, but 3I/ATLAS achieves propulsion without ejecting any detectable matter. This violates conservation of momentum unless the object is interacting with some form of exotic matter or using the quantum vacuum as a propellant source. The energy requirements for the observed maneuvers are staggering. Calculations based on the object's estimated mass and observed accelerations indicate power generation capabilities in the terawatt range, equivalent to multiple nuclear power plants operating continuously. yet no energy source signatures are detectable, suggesting either perfect energy storage systems or direct matter-to-energy conversion at efficiencies approaching 100%. The propulsion system appears to operate independently of external forces, maintaining thrust capabilities regardless of distance from the Sun or proximity to planetary magnetic fields. This independence from environmental energy sources suggests either carried fuel with energy densities far exceeding anything known to physics, or to extract energy from fundamental sources like zero-point fields or space-time itself. The pattern that connects to Oumuamua. The behavior exhibited by 3I/ATLAS bears striking similarities to the anomalous characteristics displayed by Oumuamua in 2017, suggesting a pattern of interstellar visitors that operate outside our understanding of natural celestial mechanics. The parallels between these two objects are too numerous and specific to be coincidental, pointing to a common origin or purpose that challenges our assumptions about what travels between the stars. Both objects demonstrated non-gravitational acceleration that couldn't be explained by conventional outgassing models. Oumuamua's mysterious acceleration of 17 millimeters per second squared occurred without any visible coma or tail, while 3I/ATLAS shows controlled trajectory changes despite gas emissions insufficient to account for the observed maneuvers. The acceleration patterns in both cases suggest controlled propulsion rather than natural forces. The chemical signatures of both objects defy conventional comet models. Oumuamua showed unusual reflectivity and rotation characteristics that suggested a metallic composition rather than typical ice and rock construction. 3I/ATLAS displays the impossible nickel emissions and industrial-grade chemical ratios that indicate artificial rather than natural origin. Both objects seem engineered rather than naturally formed. The trajectories of both visitors show characteristics that optimize their observation opportunities within our solar system. Oumuamua's path provided close approaches to multiple planets while maintaining a route that allowed for extended observation from Earth. 3I/ATLAS is following a similar pattern, executing course corrections that maximize its survey capabilities while avoiding potential interference from planetary gravitational wells. The timing of these visits raises additional questions about coincidence versus coordination. Two such unusual objects arriving within a decade of each other represents a statistical improbability that suggests either a dramatic increase in interstellar visitor frequency or the possibility that these objects are related components of a larger observation program. The size difference between the objects might indicate different roles within a coordinated survey mission. Oumuamua's smaller size and limited observation window could represent a reconnaissance probe, while 3I/ATLAS's larger mass and extended visibility might indicate a more comprehensive data-gathering platform. The technological capabilities demonstrated by each object complement rather than duplicate each other. Perhaps most significantly, both objects appeared during a period of rapid advancement in human space technology and increased sensitivity to extraterrestrial intelligence. The timing suggests either remarkable coincidence or the possibility that our technological development has triggered interest from intelligence monitoring our solar system for signs of emerging spacefaring civilization. Call to action: witnessing history unfold. What do you think is really happening with 3I/ATLAS? Are we observing advanced technology from an extraterrestrial intelligence, or could there be exotic physics at work that we haven't discovered yet? The evidence points to capabilities that exceed human technology by centuries.